Okay, so we've got nature of the groups. This is my second tutorial on this, looking at more involved questions. This question here, and of our revision sheet, for what value of k does the equation 3 squared kx plus 4 equals 0 have equal real roots? And as soon as you reach equal real roots, we know that it's in scenario where the parabola comes down and hits the x-axis 1, so there's one repeated solution. And so in that case, we use the determinant b squared minus 4ac equals 0. And the simple substitution, b is k squared minus 4 times a, which is 3, times c, which is 4. And we work out there. And with 4 4s, 16, 16 times 4 is 48. So it's k squared minus 48 equals 0. And we're rearranging k squared equals 48. So some number squared equals 48, so we do the square root of 48. 6.928. So we write down k equals 6.928. But then we also remember it is a repeated root. So there is plus and minus. So just to repeat that, so you've got the plus 6.928, which is k, or minus 6.928, which is k. You can write an equation with a plus and a minus in front of it as well. There's two ways of writing it. Okay, so moving on to the next one. Find the values of k for which the quadratic equation 2k minus 1 in the squared plus k plus 1 bracket is k minus 4 equals 0 has two real solutions. So there's 2 there as the indicator that we must use b squared minus 4ac is greater than 0. There are two solutions. In this case, b as k plus 1, sorry, k plus 1, is my b squared minus 4 times a, 2k minus 1, times c, which is k minus 4, and the 4 has to be greater than 0. So we must carefully expand this out. This is k plus 1 times k plus 1, which we know is k squared plus 2k plus 1 minus 4, and I'm going to open the brackets and expand these two out. Then we get 2k squared minus 8k minus a k plus 4. And now we're going to get rid of the brackets by multiplying through by negative 4. K squared plus 2k plus 1 minus 8k squared. Now 8k subtract 1k is 9k, so 9 times 4 is 36k, and then minus 16 is equal to 0. These are my like terms, so I'm going to have k squared minus, k squared minus 8k squared minus 7k squared, and then 36 plus 2 is 38k, and minus 16 plus 1 is now minus 15. That's got to be greater than 0. So this is a quadratic equation, and we're saying, where is this quadratic equation greater than 0? So quite quickly, I can grab my calculator, and I know that A is -7, B, so going into equation, F2 is 1. So I'll write that down. Equation, F2 is 1. And I find A is -7, B is 38, and C is -15. That's solved, and there we get my two values. So K can equal 5 and K can equal 0.4285. Just copy that. Now I've written them down, but what I really need to do is look at that graph, and I'm going to pop it in here, just to make sure I understand where that graph is greater than 0. So I'm just going to put in minus 7x, minus 7x, plus 38x, minus 15 onto here, and draw the equation. That makes better now. And there we go. So on there I can see that it is positive over here. So this is where that line is greater than 0. So I can simply write that K lies between the 0.428, 5, if you like, that's that point there, and all the way up to 5. So using that set of an equation there, I'm saying that from there to there, K will have this greater than 0. Okay? And you can also check that by doing G squared root, and it gives you the first one. Here you go, 0.42857, and plus 12 plus the next one, 5. Okay, so that's really the values for K positive. So yes, to draw. Okay, so the next one, a little bit more involved. This one here, just moving my page up a little bit for you. The roots of the equation, x squared plus 6x plus c equals 0, where the equation has the roots k and k minus 1. Find the values of c. So straight away, we've got to concentrate on this piece of information here. These are the solutions. So if I were to factorize these, I would write them back into an equation. X, in this case plus k, would become minus k inside the bracket, x minus k minus 1 equals 0. Now let's expand this out. So it's going to be x minus k, x minus k plus 1. Okay? And expanding that, and then you get x squared minus kx, then plus this one here, minus kx, then a plus k squared, and then a minus k is equal to 0. Alright, so now I've got that, I need to get in my like terms, and really concentrating on my x squared and my x terms. Looking at this closely, I've got 1 x squared here, it's gone, and then these values here are all x values. In fact, I've got minus 2 of those. So if I put a minus, just to keep it simple, I'm going to put plus k and then put a minus 2k, because x times minus 2k will give me minus 2k. And then I need a plus 1 to give me this x squared. So that's all taken care of. And then down in here I have k squared minus k equals 0. Now let's just compare that with our original equation. So we've got x squared, then here we've got a 6x, and here we've got a c. So this is c, this is 6x, x squared. So quite quickly we can see that 6 equals minus 2k plus 1. So we could rearrange that and page up. Take the 1 across, that is 5, equals minus 2k. Take the 2 across, is 5 divided by minus 2 equals k. So therefore k equals negative 2.5. Looking down here, we know c equals k squared minus k. We found out what k is, so we substitute in 2.5 minus squared minus 2.5. We keep that, and that comes out as 2.5, using my calculator, and bracket, minus 2.5 squared plus 2.5, because the minus plus equals 8.75. So that gives me the value of C. So the value of C put back in here would therefore give me two solutions to K, minus 2.5 and